Welcome to the last podcast in the series of stoichiometry, limiting reactants, and percent yield. This podcast is about stoichiometry, limiting reactants, and percent yield. In fact, it is problem number 9 from your web assign. It's a doozy. And in fact, there's a curveball in there that really isn't a curveball. It's just to throw you off. Let's get started. The problem says when elemental copper is heated with sulfur, a mixture of CuS and Cu2S is produced, with CuS predominating. I don't know if I said that right. What is the theoretical yield of CuS, CuS, when 39.1 grams of Cu is heated with 58.5 grams of S? Assume only CuS is produced in the reaction. So there's the curveball. You don't even have to worry about that stinker bonker. Just forget it. So we need to look at our problem. We have 39.1 grams of Cu, copper, and 58.5 grams of S. When you're given the amounts of both things on the left-hand side, it means it is a limiting reactant problem. That means we have to find out which one of those is used up completely or runs out first, and which one is an excess. In this problem, we're not going to use the excess one at all, so we're just going to find out which one's the limiting reactant. And we'll find which one is the limiting reactant by looking at CuS. So we'll do stoichiometry from Cu to CuS and from S to CuS. And the one that produces the least is the number we'll put in here. So clearly the answer is already given there to you. The least one should produce 58.8 grams, and then we'll do the percent yield calculation. So we're going to do 2 lines of stoich. We will start with copper. We have 39.1 grams of copper, and we're going to do stoich from copper to CuS. We'll change it into moles, so 1 mole of copper has 63.55 grams. We'll do the mole ratio. It's balanced up already, so there's 1 copper for 1 copper sulfide, CuS. And now we change those moles of copper sulfide, or CuS, because it's more fun to say that way, into grams, which is 95.61 grams, and that gives us the 58.8. That clearly must be, that is the answer. You can see it over here. So the copper must be the limiting reactant, but let's check. If we didn't have that answer there in front of us, we wouldn't know. So we have to do a line of stoich then from the sulfur to the copper sulfide, and that number is 58.5, so we'll do 58.5 grams of sulfur, change it into moles. 1 mole of sulfur is 32.06 grams. Do the mole ratio. There's 1 sulfur for 1 CuS, and then 1 mole of CuS, we can just copy that number from up here, is 95. That's a lovely 5.61 grams. I added up the Cu and the S. And that gives us 174.5, a huge number. In fact, you could have done some mental math with that. You could have looked and went 58.5 divided by 32 is probably a way bigger number than 39.1 divided by 63.5, since at the end you're multiplying by the same number. So at the end of the day, we really didn't need to do that second line, but what we did to compare it. So we actually produced 58.8 grams of CuS, and that's why that answer goes there. And now we'll work on the percent yield. So the last part is, what is the percent yield of CuS if only 36.9 grams of copper Roman numeral 2 sulfide can be isolated from the mixture? So that is the actual amount that you get. So you actually get 36.9 grams. But in theory, if you were to do the reaction with perfect conditions, you should get 58.8 grams. So 58.8 goes on the bottom because that's what you get in theory. Times it by 100, and you get 62.7% yield. And that is why that answer is right there. I hope you enjoyed this exciting, fun time with stoich, limiting reactants, and percent yields. I bet you couldn't have done anything more exciting than this. Until next time, good day.